Alright, so we'll be looking at tricks to find the redox. So how can you solve a redox reaction? And I've given an example. I'll be able to explain one or two things. So the thing is, let me go through steps on how you can best actually answer redox questions. So the first thing that we need to understand is, suppose you're given, let's say, a reaction to say, we need to know elements. Let me start like this. Elements in group 1, they have a valence of 1, and that's their oxidation state. Element in group 2, they have a valence of positive 2. They give, in short, ions of 2. Then elements in group 3, they give that 3 also. Elements in group 4, they give also 4. Then elements in group 5, these ones, they give a 3. Okay, that's the oxidation state. Element in group 7, 6, they give 2 as well, like oxygen. Elements in group 7, they have 1. Elements in group 8, they have a 0 valence oxidation state. So if you can know these, then the next thing that you need to know is, how can I actually deduce the values of that? Suppose we're given a compound to say, okay, I have carbon dioxide there, okay, then I am asking you to find the oxidation state of oxygen in this carbon dioxide. So what you do is find the oxidation of state of carbon. So what you do is, the whole compound here is charged what? There's nothing, so that is 0. So sometimes I can write to say, okay, this compound is charged -2. Okay, so what you can do to find the oxidation of oxygen, of carbon dioxide, you say, okay, there's 2 times for oxygen, which is just hidden. There's oxidation state for oxygen that you know, so that will give you -4. Okay, so this means that you equate to what was charged there, this top charge, which is -2. So this means that we have C plus, that will be minus again 4 is equals to -2. So that means that we have 4 minus, that is -2. When you take 2 to the other side, that will be C plus, C is equals to plus 2. Okay, because it will be positive 4, and that will be the oxidation state. So what I'm trying to show you is, I want you in a situation whereby you are able to deduce. Suppose the same previous example I gave now, carbon dioxide 2 there, now its charge is 0 there, right? So what you can calculate, the way you can calculate the oxidation state of carbon, you say, okay, 0, this oxygen, it has a valence of -2, that is hidden, say. So you say plus, open bracket, the 2 that it has down there, the number of oxygen, times the oxidation state, which is 2. Then the whole compound is charged 0, so equate to 0. So you say C plus -4 in the bracket like that, then it's equals to 0. So this means that we have C minus 4, then it's equals to 0. So this means that carbon here, it has the oxidation state of 4. So these oxidation state, they will help us to find the they will help us to find the which one is reduction, which one is oxidation in that reaction. I'm very fast. Why? It's just a matter of revising. So the first step that we need to do is, when solving this redox, you divide. Okay, Maparo, are you there? So you divide into a half reaction. Okay, so half reactions. When I say this, you divide. So how do you divide? By choosing the main species. That you find 2 main species in each compound. Let's say the metal species or the sulfur species. Apart from oxygen and hydrogen, those will be your main species, whatever you find apart from those. Then the other thing is, so you divide, you divide, then you'll tell whether it's oxidation or reduction using the oxidation state that you'll be calculating for each species. So we'll talk about that. Then the other thing is, you balance. So say balance. Alright, balance the electrons now. After balancing, so you balance the electrons and the atoms and the main atoms or the main species. Alright, then step 3, you balance oxygen. So balance oxygen to the side where it's lacking by adding water molecule. I'll demonstrate this. Balance oxygen by adding H2O, because that will give you 1 oxygen molecule there, 1 oxygen atom. Then we balance hydrogen. So you balance hydrogen also by adding hydrogen ion like that. So if you have a lot of hydrogen, let's say 2 there, you write 2 there like that, you have balanced oxygen. From there, then cancel, you see now reciprocate the number of electrons that has balanced. Anyway, I'll explain this. Let's go to this example. Okay, so the first example that we are given there is we have ion there. Okay, ion 2. Okay, 2 plus this one has already detected the oxidation state and uh, the oxidation state and the reduction, I mean the oxidation half reaction and oxidation half reaction. So there's 7 there, then -2, then giving us I think, let me change the background so that we can see. Okay, let me just continue with this. Then we can see now we have ion 3 plus, then plus chromium 3 plus. So you can tell this one just by looking, it has increased its oxygen, like it has given a lot of electrons. Once you give an electron, that is oxidation, you are oxidizing, so that is oxidation reaction. So I'm breaking now into half. Then once it's actually reduced from, I don't know what chromium had, but I can still calculate the chromium there. Let us calculate the chromium oxidation state. So we have chromium 2 there, oxygen 7, then -2, like that. How do we calculate? We say chromium, it is 2 of them, 2 chromiums, alright, there's 2 there, 2 chromium, then plus, we have 7 there, oxygen we said is charged -2, so say 7 times -2. So the whole compound is equated to what? Is charged to -2. Okay, so what you do is say, okay, I have 2 chromium, okay, then minus 14, then is equal to -2. So when I take that one, it will be +12. So have 2 chromium is equals to, when you take 14 to the other side, that will be 12. So that will be +12. So you divide throughout by 2, so that will be 6. Okay, in short, chromium is having +6 as the oxidation. See, it is having 6 and it has reduced it to 3, so meaning that there was adding of electrons, so hence reduction, because an electron is negatively charged, so there was an addition of how many electrons? 3 electrons for them to reach at +3. It's more like we have 6, then we add the 3 electrons. Remember, electrons are negative, so hence they'll give you +3. So that's how you can calculate the oxidation. So this is how the coming up of this number of written to say oxidation, stuff like that. Okay, so that's how you can handle that. So the other thing that we need to understand is, let's go now and see, since I've broken down into half reaction, and you have seen how it is actually coming up to that. So oxidation is the loss of electrons, then reduction is the gain of electrons, so master those. So now the way we can now, since we have half reaction, so I'll get I'll get the first one. Okay, let me use it even in red. So the oxidation, let me get the first one, which is Fe plus, then giving us what? Fe plus 3 there. So there's no need of balancing these coefficient atoms. It's okay like that. The only way we can balance are the electrons that we can see. On top we can see how many electrons they are. What? They are 2 electrons this side, here they are 3. So we'll add 1 electron there, because an electron, so you add positive something was negative, that will give you 2. Okay, +2, because electron is just a reduction. Alright, so that is about for that oxidation state, oxidation reaction. So let's talk about, so this was the first one. Let's talk about the second one now. The second one, we have chromium 2 there, oxygen 7, then -2 there, then going into what? Chromium 3 plus. Okay, so how do we handle? We can balance the oxygen by adding oxygen on the side where it's lacking, so add their oxygens, and if you can add the oxygens there. Okay, remember the oxidation state here, it's 6 plus. I don't have to show this, I've already calculated it, so it's in my mind now. So how many oxygens? We have 7 of them there, so I'll add 7 water molecules, that's the meaning. So I'll say, okay, 7 H2O on this part where it's lacking. So this means that the 7 is multiplying those oxygen and making this 7 which is there. Okay, so that's the meaning there. So from there then we can see that we have extra hydrogen, 14 of them. So we'll bring, how do we balance the hydrogens? Remember, anyway, I'll come to that, but how do we balance the hydrogens? So we'll balance the hydrogen by what? Let me balance the hydrogen on the side where, yes, since we have made 14 hydrogen, I'll add 14 hydrogen there. So I'll say chromium 2, oxygen 7, then negative 2, then plus hydrogen. So now I'm adding how many hydrogen? 14. So about hydrogen ion, you add hydrogen ion, so say 14. Okay, 14 hydrogen ions, like that. Hydrogen ions positively charged like that, then is equal to the same thing. Okay, 3 plus, then plus 7 H2O. Okay, so what is remaining here then? We just balance the number of electrons. Remember here we have 6 of them. Okay, since there are 6 plus there, plus this 14 plus, okay, plus this 14 plus, that is making how many? So you're looking at the number of electrons, so you add all the electrons that you're able to see there. So that will be the goal. So this means that we have electrons there 6, we have also 2 electrons there. Okay, so we have also 14 electrons there. So this and this one, they are giving 4. So we have 4 electrons there, positive 4. Then here we have 14 plus 14, so that is giving 18. Okay, so the total electrons that we have is 18 now. Okay, so these electrons is by investigating, that's when you get to know. Okay, so from this compound we are getting 4 electrons, then here we are getting 14 electrons. So here is 14 electrons because of their ions there. Okay, so meaning that they are making 18, so we have 18 electrons there. So how can we balance? Here we have 3, so meaning that for us to reduce to 3 and we have 18 this side, we can add, these are positive electrons, so we can add how many? 15. We can add 15 electrons like that. Okay, so that we can have the total of 3 because these guys are just neutral. Okay, okay, so this means that we can add for the side where it's lacking the electrons. So say, okay, we have chromium there, chromium 2, oxygen 7 there with a negative 2 there on top, then plus 14 hydrogen ion. Okay, you write plus there on top, then plus how many are we adding? We have 18 of them, so we're adding 15 electrons, then giving us chromium 3 plus plus 7 H2O. Alright, so that's how we can approach this. So the next thing that we can do here is we'll say, okay, I've balanced everything now, the electrons have balanced and everything stuff like that. So it's now to bring these two equations. Let me bring the lead one. So if I'm to bring the lead one, so I'll say the lead one is Fe, so Fe2 plus giving us Fe3 plus, then plus 1 electron there. So that's how you can balance. So now you can reciprocate the coefficient of those electrons. So this will be multiplied by 15 because we have 15 electrons coefficient. Then this on top, it will be multiplied by 1 because we have 1 coefficient there. So you reciprocate. So there we have 1, then here we have 15. Okay, so this means that, let me lab on top there so that we can have enough space. Okay, so what I'm trying to say is here the first one will be multiplied just the way it is. So we have chromium 2 there, okay, then we have oxygen 7 there, then to the power negative 2 there plus that 14. Okay, I'm adding all the even the main species. So let me do this. Let me add the main species. So I'm bringing this one is being multiplied by 15, so that will be 15 ion 2 plus, okay, ion 2 plus, then plus the same 14 number of electrons we had, I mean 14 hydrogens, okay, 14 hydrogen plus, then plus we have 15 electrons, then plus, okay, we are adding again, we are multiplying 15, I'm bringing this main species, this chromium, so we have, no, I'm not supposed to write plus there, I'm done with the reactants, so giving us, so we have the chromium, I have chromium with 3 plus there, then plus we have the ion 15 ions like we stated to say the reciprocal will multiply, then 3 plus there, then plus H2O there, 7 H2Os, okay, plus 7 H2O. Alright, we can see now the number of electrons are cancelling. Okay, did I add the number of electrons there? Yes, we need to multiply the number of plus the number of electrons there, 15 of them. Okay, so this number of electrons, the 15 number of electrons you have there, they will cancel with that. Okay, then what will happen is that our equation now we are done, so what is remaining is just to finalize it. So we have chromium 2, oxygen 7, negative, plus 15 E there, 2 plus, then plus 14, okay, 14 hydrogen plus, then we go there, then that means we have chromium 3 plus, then plus 15 ion plus 3 there, then plus 7 H2O. Alright, so this means that by the presence of removing this, we have remained with, we are in acidic media, so this is acidic media. Okay, so now if you want to take in base media, okay, now base, so the presence of remaining with this hydrogen ion is acidic, so if you want to take it now in basic, this is where it is simple, and what you do is so what you do is you say okay, I'll add hydroxide ion so that I make the waters here, and the presence of hydroxide again, it will show you that you are in basic media. So what I'm going to do is I'll add the hydrogen where to the side where it's liking, so I'll say okay, 2 plus there, oxygen 2 there, 2 negative, plus 15 ion 2 plus, then okay, then we have 14 hydrogen ions, then we add, now we are balancing this hydrogen ion, so we're adding how many hydroxide, we are adding 14 hydroxide, it's an ion also, they are ions, so giving us the chromium 3 plus, then plus 15 F3 plus, there's E there by the way, there's E there that I've forgotten, then plus 7 H2O. So the goal is to cancel this, so here will form the 14 water molecules, that's the meaning. So we are going to say okay, Cr2 oxygen 7 2 minus plus 17, I mean 15 Fe plus 2 plus, now we are making 14 water molecules. That's the meaning there. Okay, 14 water molecules, then giving us chlorine plus, chromium plus, then plus 15 Fe3 plus 7 H2O. So this means that we have 14 water molecules this side. Here we have 7. So when you cross multiply there, we'll remain with, by the way, one thing I forgot is when I added this hydroxide here, I was supposed to add also there. Okay, so I was supposed to add hydroxide, those 14 hydroxide, so I'll add them there. There are 14 hydroxide. Okay, okay, you add on both sides. So I find that there's water here, that there's 7 water molecules and we have 14 water molecules. This means that we'll remain with the, when we bring this, we'll bring to the bigger number, and that will subtract the 14 water molecules. Hence we are going to have chromium 2, oxygen 7, 2 negative there, plus the 15 E2 plus, there will remain with only 7, because the 7 from the right side will also subtract there of the 14. So we'll remain with 7 H2O. Okay, then is equal to chromium 3 there, then 15 Fe3 plus, then plus the 7 has gone, the 7 water molecule has gone. What you have remained is 14 hydroxide, like that. So hence this actually concludes the how you can balance it in acidic media. In basic media, because the presence of those 14 water molecules proves that you are in acidic media. You are in basic media. All right. So let me solve another equation so that we see. Now I'll leave it in acidic media. Okay. So what we do is, hello, go online. So what you do is, okay, so let me just do something. Just a moment, let me get a question paper. All right, get a question paper so that we can see what we can do. Okay, where is that paper? 20. Okay, where is that paper? Okay, all right. Where is that paper? Where is that paper? Okay, just take a question paper so that I get a question, so that we are not bored in what we are doing. Okay. Okay. Okay, I've found the question paper. Let me just do this. All right. All right. Is it okay? All right. Okay.
a negative there, then plus we have Fe there, which is the ion. So this Fe is charged with 2 plus there. Then we have is given as H plus. It's already given whereby you can spice it. Even the hydrogen has been added, meaning that this is a sweet question. Okay, so they can bring n questions, so you have to be actually robust with whatever scenario they can bring. So 3 plus there, then plus H2O. This was somehow very straight. So H2O, it's already complicated, I think. I mean, it's already done. So the again is for you to identify which one is the oxidation half reaction, or but this one can tell already to say it is looking at the main species. So oxidation reaction, so this is oxidation, hence this will be reduction, but you can still calculate there. Let's calculate the oxidation state of this guy in that compound. So we'll say Mn, okay, then plus that 4 times the oxidation state of oxygen, then is equated to -1. Okay, so this means that we have Mn is equal to, alright, so Mn is equal to that will be, when you go there at 6, that will be +5. You have seen that is reducing, that is reduction. Alright, still it's +5. Alright, so now let us see how we can handle it. So the first thing that we need, you have already broken into half reactions. So the oxidation half reaction, let me start with the oxidation half reaction. So the oxidation half reaction, so it's given as Fe 2 plus H2. I mean, no, I don't have to include these oxygens. I'm just looking at the main species. Alright, so it's giving me what? Fe plus 3. So it will be just a matter of balancing electrons here. So I'll just add an electron to the side where it's lacking. So I'll add an electron. I'm done with the first equation. Okay, let's go to the second equation. So you look at now, we have manganese there, manganate, then we have 4 there, negative there, then plus, I mean giving us Mn the power 2 plus there. That's the oxidation state. Forget the rest, but I can still add this because it's having oxygen which is balancing it. So I'll bring oxygen also, which is the H2O there. Is that okay? The hydrogen now, forget it, we'll balance it later. Okay, so what we do is now we're going to balance the oxygen to the side where oxygen is lacking. We have 4 of them, here we have 1. So add how many hydrogen? Okay, we have how many there? We have 4 of them. So how many water molecules should we add? Okay, how many water molecules should we add? We should add 4 of them. So what you can do is, I can add 3 of them there to say 3 H2O, but I already have there. So this means that I have Mn oxygen 4 negative there, then giving us, we have Mn there, okay, 2 plus, then this will be 4 water molecules. So that's how far I've added it. Then now it's lacking with the hydrogen ion. I've seen now I've brought the confusion of 8 hydrogens. So I'll say, okay, I have Mn there, oxygen negative there, then plus, since that side there is 8 hydrogen from the water molecule, so I'll say 8. Okay, I'll add 8 hydrogen ions.